heard types of machine learning algorithms before? Have any of you heard of what supervised learning or unsupervised learning is? Have you all heard of these two terms before?
Okay, not many, but we're going to learn it.
We're going to learn what supervised learning is, unsupervised learning is, and what reinforcement learning is. Now, supervised learning is basically when you're training a model with data that is labeled. Now, what do I mean with labeled data? Does anyone know what labeled data refers to? A very easy question.
Data. What a label is.
Oh, what is a label?
A name, yes, a name for what? Label the use syndrome.
Well, what do you label? You label images.
Identification, yes. Or a tag to identify something, to associate something for job.
That's right. Supervised learning is when you add labels to your data when you train your model. So for example, over here, we go to the previous slide. For example, we have a set of vegetables over here. Now when we're inputting the data into the model, supervised learning is when we label the data. So we can say this is a carrot, or we can label the other vegetable with its name. Then it goes through the model, then we can train the model in order to make a prediction on which type of vegetable it is. That is the basics of supervised learning.
Alright, so supervised learning look, two tasks here. What are the two tasks? We talked about it before. One starts with C. Yes, classification, and the other one is regression. What is the difference between the two? Let's start with regression. Regression means we are dealing with values. So maybe number, numerical values are input. We're not dealing with categories. Look at this example over here. I want to predict what is the temperature going to be tomorrow. Will it be 84 degrees? In our terms, would it be 30 degrees? Would it be 40 degrees Celsius? How will I train a model to do this? It is a regression task. It is a machine learning regression task. So your first job is, or project 109, you have to think, what type of task is this? Is it classification? Is it regression? Do I need a machine learning model? Do I need a deep learning model? You need to understand how to apply these concepts to your project. That's why we're telling you the difference here. So with supervised learning, with regression, given your input variables, given x and y, you are going to be predicting. So typically you have your x values and you will be predicting the y, which is your output.
We also talked about classification, and as we mentioned, classification is used when you want to perform data analysis and when you want to classify data into specific categories. So for example, using an x value such as temperature, we can classify whether a day will be cold or hot into two specific categories. So that everyone understood the difference between regression and classification.
Do you all understand? Okay, quick question. Now I want to predict the price of a house with a machine learning model. Is this a regression or classification task?
Okay, I'll make the question a little bit easier to understand. We want to predict the price of a house using some features, such as the number of rooms, the number of bathrooms, the number of kitchens, and all of that.
And price is going to be a numerical value. Regression or classification?
It's a regression or classification now.
I can make sense, but decide here more of regression. This is going to be a regression problem. Why? Because your output, what you are trying to predict, is a numerical value. For example, let's say 10 lakhs, 20 lakhs. That's going to be your price. Now, I'll give you another example. What if I want to predict what type or what color a particular, let's say, phone, or what brand a particular phone is. So this can be used in airport security, or it could be used in any other use case where you have different tech devices going through a scanner. And I want the model to output the brand or what type of device this is. If it's a camera, if it's a phone, if it's a cell phone, mobile. What is this? Regression or classification? Yes.
Classification, that's right.
So you understand. We have regression for numerical output, we have classification for categorical output. So you need to understand what type of task you have. Alright, so we discussed this. This is the chart of machine learning. Machine learning, you can split it into supervised, unsupervised. We're starting with supervised. What do we learn? Under supervised learning, we have two types of tasks, classification and regression. And now these are the algorithms that we use. Now we're not going to go in depth, but we want you to do the exploring here. Once you practically understand, so in the task here, in the model use pointer. Once you have that understanding, you will be able to create your own models. So that's what we want to do. But for classification, we typically use decision trees. We typically use something called k-nearest neighbors. There's a lot of mathematical formulas that come behind these. We will discuss some of them in our PPT today. Alright, so a very easy way for all of you to understand is we're going to break a machine learning algorithm into three parts, three components, okay? So when you're designing a project and when you're choosing an algorithm, break it into three parts. What's the first part? First part, give it a
So what is the first
It's
part?
on the screen.
It's on the screen.
Representation. Okay, second part, optimization, and the third part. Wonderful. So when you are designing a machine learning project, your algorithm must have a representation, optimization, and an evaluation. What do I mean by representation? Representation is which algorithm or which function to use. So am I going to use k-nearest neighbors? Am I going to use a decision tree? That is going to be the first step of selecting a representation for your model. What algorithm, what function? Next is optimization. How can we improve the accuracy of our model? So in our model, we're feeding so much data, நிறைய parameters இருக்கும். There are different parameters, especially in machine learning. You have learning rate, epochs. We won't go into the depth, but you need to understand, in order to get better accuracy, what do we need? Optimization. And there are different ways or optimizers to use to optimize your algorithm and improve the accuracy. What is evaluation? Evaluation, the English word.
What do we mean by evaluation?
Testing.
That's it.
You trying to pause 3 seconds ago, the people were answering. Testing. You cannot deploy a model into the market without testing. In today's world, there's so many different types of AI and ML models being developed, but why are we not using them? Even autonomous vehicles are not full-fledged because they're still undergoing proper evaluation to pass the minimum required accuracy. So these are three things that you will be doing when you are creating your own machine learning model. Representation, optimization, and evaluation. Yes.
Okay, I have a quick question. How many of you have created a machine learning algorithm or created a machine learning model before?
Have you tried before? Okay, not many. That's a new thing. So in today's workshop at the end, anti-project area, there are micro projects, and I want you guys to think about how you can implement those projects too. So here we have some metrics, evaluation. How can we measure it? Accuracy. So I can say my model has an accuracy of 0.83, that's 83%. 0.93, 93%. This will tell you the feedback on how your model is doing on your test data.
Now we have a lot of other evaluation metrics that you can also use depending on what you need. You can use accuracy and a lot of other measures such as precision, F1 score, and recall, and we'll be going through this in our projects. So we have clearly listed out all the classification metrics in our projects that we're going to do.
Now, a very important thing is, we talked about why machine learning models are not accurate. There's another problem you will encounter when you are creating your model. It is called overfitting. Overfitting na yan ang not really, but this is important. See, so many people, they try building their own project. They try creating their own model, but then they will stop because it won't work properly. Or a high accuracy barabar. So they just give up on the project. But you need to understand, in the training process, there are many challenges. And we want to tell you how you can fix or overcome those challenges. Overfitting is very simple. For my model, I am giving, let's say, 2,000 different images, or image classification model, 2,000 images. I'm going to take 1,500 images for training. So the model will learn the features, upload 500 images for testing. And the model gets an accuracy of, let's say, 0.95, 95%. Is this good or bad? Good or bad? So that was good.
Is 95% accuracy good, or is it not good?
It's good?
Good.
Yes, it's good. But there's a problem. When I feed in new data, okay, so let's say new 100 images, guess what? The accuracy is just 0.50%, 50% down. Why does this happen? When I train the model, 90% accuracy on the chip, but then when I do the project in real life, when I feed in new test data, it does not work well. Why does this happen? Overfitting. Overfitting happens when your model trains or fits too close to the data you feed in, to the test data, and for new data, it does not generalize. There is this term called generalizing. So when you are making your own machine learning model, you need to think, can this model generalize to new data? That's the most important thing.
Okay, before we go on to our level 2 quiz, I believe the majority of the terms that we are discussing in this session are new to all of you. So does everyone have a notebook with them?
How many of you have a notebook?
Do you have a notebook and a pen?
I think some of you do. Please, when these are new terms, please make a note of them, take it from your friends, and explore them.
You can also use a lot of sources for you to learn programming or just projects in general. Now I'll give you one specific website that you can use in order to learn more about ML projects. It's a website called Kaggle. If you have a notebook, you can note this down. It's spelled as Kaggle.
How many of you have heard of Kaggle before?
Kaggle.
See,
Okay, you're one answer.
Good, but I want everyone in this room to create a Kaggle account. Kaggle under a platform where they have open source machine learning challenges and projects. For example, you saw house price prediction. It's all Kaggle. So, nariya notebooks irukku, nariya codes irukku, and you can use that data set to train your own models. This is how you practice your skills. On Kaggle, you have hundreds and thousands of different types of projects you can do. And they have certificates. You can finish these projects, you can showcase them on your portfolio, on LinkedIn. So please do this because this is the only way you are going to develop your skills. Okay, Panamorika? It's Kaggle, it's Kaggle. Alright, let's start with our quiz.
Shall we go on with the second quiz? Is everyone ready?
Diploma?
Shall we start?
Alright, let's begin.
Okay, in supervised learning, what are the two main components of the training data?
We spoke about supervised learning, the difference between supervised and unsupervised. Main thing.
Does everyone know the
What are the two
answer?
components?
What are the two components?
Right, please come up.
Please come up.
Yes. Huge round of applause. I want more encouragement, more energy. Yes, please come. Any other volunteer, please come up. What are the two most important features? Option A. We have the answer.
Option A.
Okay. Is option A correct? Features and labels.
So we think option A is right.
I need a strong answer from the audience.
We need a loud answer.
Yes or no? Yes. Okay,
Yes.
good.
That is the right answer. Great job. Now the second question. In supervised learning, what is the primary purpose of a test set?
Remember the third step, evaluation. Why do we need testing? Why do we need evaluation? It's a very simple question here. To evaluate the model's performance on unseen data, to fine-tune hyperparameters.
Is it to provide additional training data or to make the model memorize the data?
Okay, this seems to be a bit of a hard question. Quickly, everyone volunteer, come on.
Why do we need to perform testing for machine learning model? Yes, please come up.
We want some more answers from this side. Please come up. Yes.
Yes. What is the option?
So,
Option A.
To evaluate the model's performance on unseen data. So, unseen data is my answer.
Yes, that's right.
New data. That is the correct answer. Huge round of
Huge round of
applause.
applause.
New data. In order to test the model, can the model actually predict new unseen data? You need to do evaluation or testing.
There is for the next question. Which metric is commonly used to evaluate classification models in supervised learning?
You saw this metric. What is the answer? I want the answer from the whole audience.
It's a very easy answer. What metric do we
What is the
use?
most common metric? Okay, let's do a countdown. 3,
2, 1, what is the answer?
Is it A, B, C, or B? Alright,
B, that's right.
Amazing.
Yes, the answer is B.
It is accuracy. This is the most commonly used metric for classification. There are metrics in good, and for the basic ones, we want to go with accuracy.
Okay, what is the purpose of cross-validation in supervised learning?
Okay, cross-validation. You might have not heard this word, Anna. Evaluation that we do this thing called cross-validation. Again, remember what I said. Overfitting. We need to make sure that the model works on not just
asked, is that right?
Yes. Huge round of applause for all of
Okay,
you.
come on.
Cross-validation is to perform the evaluation on multiple test data sets. Alright?
Let's go on to the next question. In supervised learning, what does the term overfitting refer to? We discussed about this term overfitting.
I want one volunteer to please come up for this. One volunteer from this side.
Yes, we want to volunteer for this question.
Alright, we have the same person coming up. Yes, you
Yes,
want to come up.
please
I
come
want
up.
one person to come up.
We need one more person to come up.
What is overfitting? We talked about how models overfit to data sometimes. It's not good.
Option D.
Why?
Why do you think it's option D? Please face the audience and you can tell the answer.
Results in training data higher than it may be results poor in new data.
You can speak it down. Yeah, you can talk about what is overfitting and why the option is D.
Or training setup வந்து அது நல்லா பெர்ஃபார்ம் பண்ணுவோம் பட் when நம்ம டெஸ்ட் டேட்டா செட்ல நியூ டேட்டா கொடுக்கும்போது கொஞ்சம் அக்யூரசி கம்மியா இருக்கும் ரிசல்ட் வந்து போரா இருக்கும்.
Okay, one more give a round of applause.
Thank you so much. The reason I asked you the question is he was able to explain it to all of you, and that's a really good skill. So I know in this group some of you have not done projects before. That's okay. Talk to your friends. Ask people who have done projects, who know about algorithms, to help guide you. This is going to help you learn. Narrative said that they needed someone to guide them or mentor. The mentor can be your professors, it can be even your friends who have knowledge. So please take that initiative to learn. So, overfitting, when the model fits well to the training data, it performs well when you test it on the data. But then when you have new unseen data, it is not able to generalize. This term generalize is very important, alright? Yes. Okay, let's go to our next topic. Data pre-processing. Now something very important is real world data is not perfect. What do I mean by this? Data is an area of missing values. If I want to do a project, let's say I want to estimate the amount of solar energy produced from a solar panel. Solar panel, everyone knows, right? Now I want to estimate the amount of energy a solar panel produces. And then I get the data. So my data shows, okay, I have January 30 days. On day 1 I have this much energy. On day 2 I have this much energy. But there's a problem. You have January, February, but then in March you have only 5 values. There are over 20 missing values in the data either. What do? Your machine learning model is only as good as the data you feed into the model. You need to understand this. When you feed in biased data or when you feed in data that is not good quality, the model it's not going to achieve good accuracy. So if you're ever frustrated, accuracy, but if you're ever frustrated about this, think about the data that you are using. So how can we try to fix data? We do this step of data pre-processing.
Now with data pre-processing, you can do as what Harpita mentioned to fill in missing values. But you also need to look at something called outliers. Has anyone heard of this term outliers?
Outliers. English outliers.
What is it in English? It's a very easy term.
Okay,
We have unwanted data.
What about abnormal data? It could be abnormal, yes, it could be unwanted.
That's right. Now when we talk about outliers, it refers to abnormal data or data that does not fit into the pattern. For example, if you're doing a regression house, if you want to predict the house prices, and if you plot a graph, let's just say the data points are increasing. You have it in increase in order like this, but just one point is in the incorrect position. Then what do we call that point? An outlier. That's right. This is an example of abnormal data. This is what you should look out for when you want to pre-process data. You can fix all of these issues when you feed in data into the machine learning model.
So as soon as you get your data set or your raw data, what's the first step? Pre-process that data. Check for missing values. Segregate the data into a test set, train set. So remember my previous example, 2,000 images in that. I could use 1,500 images to train my model, then 500 images to test the model. Some people use 20%, 80% split. We call it a train and test split. Now, after you do that, missing data, we can do something called data imputation, fixing missing values by calculating the average. Don't worry about the technical terms. Anna, what is the technique of data imputation? To fill in missing values. So these are some of the essential things to get a higher accuracy on your model. You cannot create a machine learning model without pre-processing the data. So in the 5 projects we are going to see, you will see the different pre-processing steps in code and how we do that in real life.
Go to the next slide. Okay, I talked about that we would discuss the machine learning pipeline. Now, typically in a lot of renowned companies, when they want to perform projects related to machine learning, they would want to do something called an end-to-end machine learning project. Now, when you want to perform a project at such a large scale, you need a structure, right? A process and how you structure each specific step of the way. Now, this is exactly why you need a machine learning pipeline. Now, the machine learning pipeline is very similar to the structure that we discussed before. What is the first step in the machine learning pipeline?
Fundamental source for any machine learning project. Starts with D.
Starts with D.
Data.
Data.
Yes.
Now, what do you have to do with the data as the first step?
Collecting
Okay,
data.
collecting data, that's good.
What do you do after collecting data?
What's the second step?
Pre-processing.
Data
Yes.
pre-processing, that's right. What do you do after data pre-processing? I want all of you to answer this.
Give us some answers. I have segregation. Okay. What else? So I have my data. I clean the data. Fixed any missing values. Now, what do I use this data for? Yes, I got the right answer. Can I use training the model? What are you trying to do? Why did you get the data? To train your model. Once you finish the data pre-processing phase, you are going to feed that data into your machine learning model. What is it going to do? It's going to learn. We talked about this. It will learn the features of the model.
Now, after you train the model has now learned the patterns or features in specific images. After you train the model, what do? In order to get the accuracy of the model? What is that term called?
Okay, got the answer. Can I hear from everyone?
Evaluation, we got the answer, evaluation. Can we hear from everyone else?
What is the third step when we have a machine learning algorithm? Do you guys remember?
Well, what do you do after you train the model in order to test its accuracy?
Representation, optimization, and
evaluation. That's
yes.
good. And after evaluation, you do have additional steps when you want to perform machine learning projects at a very high scale. So you have deployment. That's where the machine learning models are being used in the real world.
And if you're wondering how do I deploy these models, again, very simple. Frameworks like TensorFlow, we saw libraries, Keras, they have predefined functions to deploy. It's so simple to the point where you can say save model, you will get it as a .hp5 file, and that can be integrated with the website. It's that easy to integrate and develop a full machine learning model and deploy it into the real world. So if you're ever wondering how can I do this, the answer lies within the tools, Keras, TensorFlow, scikit-learn. You need to explore the different functions and the different processes within these tools.
So has everyone noted down these libraries that we had mentioned earlier? Have you noted down scikit-learn, matplotlib, Keras, and TensorFlow?
Can we name some? Please tell me good. I want to hear some frameworks, libraries.
Well, what did we discuss today? What libraries did we discuss?
All of you try this answer.
Okay, we have NumPy,
Pandas,
matplotlib, Pandas,
TensorFlow,
scikit-learn,
scikit-learn,
Keras,
Keras,
that's right.
Python and programming language, basic. Wonderful. Most of these frameworks and libraries use Python. So in order to access the functions, your code must be written in Python. Alright? And some of you said pandas, NumPy. NumPy can be used for number expressions. Mostly your data can come in a CSV file where you have a lot of input values. In order to process this, you can quickly use NumPy. It can calculate the average, it can calculate the number of data values per column, per row. You don't need to sit and program every single line. So please use these libraries and tools.
And if you want to know how these libraries are used, you can go on to Kaggle and search for specific products. And in each project, you will have certain sections. You will have the data pre-processing section, you have the training and evaluation section. If you click on data pre-processing, you can exactly visualize and take a look at how the data is being processed. So in that specific section, it will be mentioned on what type of library is being used. Whether it's pandas, NumPy, you can take a look at all those projects on Kaggle as we mentioned before.
So again, we're mentioning the most important thing you are going to learn in this 3-hour session is not just the concept of what AI and machine learning is, it's the tools and ideas. Using these tools and ideas, Mingo or Project Nandipa Kalina, that's the output of this session. Alright?
Okay, next slide. Next slide. Okay, now we come on to our third quiz. Shall we start the quiz?
Are you guys ready?
Are you guys ready?
Okay.
Next slide. Okay, what is the term for dealing with missing values in the data set? We just discussed it.
We're on data pre-processing now. So we finished supervised learning, we finished basics of AI, now we're on data pre-processing step.
We had one specific word that we mentioned.
Data segregation, data cleaning, data preloading, data imputation. What was that technique?
What is the answer? Is it A, B, C, or D?
Okay, I'm hearing some mixed answers. How many of you say A?
Please raise your hand if you think the answer is A.
Okay, you guys B? Another higher rates coming there. I see some of you raised it here, okay?
Okay, C.
I see if you had some there. Okay, D. What about D? Alright, so the correct answer is B. Data imputation. What do we do with missing values? The technique is data imputation. Don't worry if you don't know all these answers. The reason we have these quizzes is to help you learn the different terms and techniques. With data imputation, it can be simple. For a data system, let's say I have 10 missing values, and they're just numbers. I can take the average or the mean of those numbers and try to fill in the missing values. That's a simple explanation for imputation. So like this, there's so many data pre-processing steps that you definitely need to use in your model.
Okay, let's go on to our next question. What is dimensionality reduction in data pre-processing?
Now, we didn't discuss dimensionality reduction. You go to page note. I'm going to put it in simple words. I just want to explain it to you. I'll ask you all a question. If I have a data set with 100 features and I have a data set with 10 features, now which data set will be more accurate when I train it with my model? Is the data set more accurate than I go? Quickly tell me. Is it thousands of features or hundreds of features?
Well, what do you think the answer is?
I hear hundreds and I hear thousands from some. Do you know what the answer is? Well, I can't say it's either one because more features does not mean more accuracy. Another important thing. Remember we talked about house price, right? In order to predict the price of a house, what features will you need? What are relevant features? Please hold it. This is just basic real life example.
Please give us some answers.
I hear all the answers, but I can't hear them here. Something else will do. Okay, what about the room? Number of rooms in a house? Okay, what else?
What else?
Square feet? Okay. Any other answers? What else can you predict the price of the house by? Location? Is location important? Yes. Now these are important features, but what if I include extra features? Do you think, let's say, the color of the house, does that affect its price? Not really. In your data set, you might have thousands, or let's say to keep it simple, hundreds of features. But in the data pre-processing step, most important thing is you need to use only the relevant features. What are the useful features for my problem? That is up to you. So these are concepts that you need to apply. It's not about just learning the algorithm or the name or the concept. You need to apply this in your coding.
So did everyone understand what the term dimensionality reduction means? You guys get
Reducing
this
the number
term?
of features. That's all.
That's right. Okay, the answer is D, it's reducing the number of features in a data set. Okay, can we go to the next question? Okay, we have what is outlier detection in data pre-processing?
We talked about this. Outliers. Outliers,
We gave an example for this.
identifying values that are within the normal range, identifying the mean and median of a data set,
Yes. Who would like to come up and give us the
the
answer?
data points with highest values, which one? Oh, okay, I'm getting option D from all of you.
Option D.
Identifying values that are very different from majority data points. Is this option correct?
Yes, it is.
It is.
D, that's correct.
So outliers are your data points. Now, in all data sets, you will find outliers. Real world data is not perfect, so you need to do the data pre-processing to make sure this doesn't affect the accuracy of your model.
Okay, let's go to the next question, a very easy one. What is the first step in the machine learning pipeline?
Quick, I want to give you an answer.
Quick.
A, B, C, or
Is it
D.
A, B, C, or D?
D, okay. Is that the
D.
correct answer? Yes.
That is the correct answer. Great job.
So I hope you understand the pipeline. See, why are we learning the pipeline? You cannot design a project without understanding the different steps of the project. So that's really important. You need to think like an innovator. You need to have design thinking. From start to end, how will I create a machine learning model? Your algorithm is just one part. You need to start with the data pre-processing, training, then your evaluation, then deployment, and then you can have evaluation again, a feedback loop. Understanding this will help you do your own projects, and that's how we create our own projects as well. That's how we are able to focus on our research too.
Okay, let's go to the next slide. Previous one.
Previous one. Alright, let's go on with unsupervised learning. So supervised learning platform. What do we mean by unsupervised? Okay, let's take the word supervised, unsupervised. Supervised, I edited. Supervision, I edited. What do you mean by supervision, supervised? Okay, labels,
use label
yes.
data.
Use and cross, I
Use
got
and
that.
cross.
When we use labeled data. So if I'm doing an image classification task, I feed in the image and then I give a label. Something simple. If this is a dog or a cat, I feed in the image of a dog, I label it. But when you go to more complex tasks, the thing is, who is going to label data? Have you ever thought about that? In the real world, there's so many images, data sets, but we have to sit and label each and every single image. And that's not possible for most use cases. So what do? In machine learning, there is a subset called unsupervised learning. With unsupervised learning, the model learns without labels. So there are no labels now. And if you're wondering how does it learn, the model itself will extract a particular pattern or feature that it identifies within the data that you feed it. And I'll give you a good example of how this is used in real life. So we're under unsupervised learning. The major algorithm here is something called clustering. Clustering na yung
Grouping.
Yeah, the English word clustering, grouping. And why do we use this? All your algorithms under clustering, so you have hierarchical clustering, you have k-nearest neighbors clustering. What are we doing? We are grouping similar data patterns. Now to explain this, I have a very interesting image. So I'm working on a research project right now with a mentor who is a PhD from MIT and also from the University of Chicago. The project that I'm working on is a mix between neuroscience and machine learning. I'm trying to build a neural decoder, so brain-computer interface partition. That's kind of what I'm trying to build. A neural decoder to analyze the signals from the brain. Now here is an example of clustering. So do you all see this grid, this 10 by 10 grid? What do you think this represents? At the end of it, this 10 by 10 grid, there are a lot of colored squares.
Well, what does it represent?
Does anyone have any idea? This 10 by 10 grid is an electrode that's implanted in the brain. So for the brain-computer interface, they implant electrodes in the brain, right? Or 10 by 10 chinna array grid. And in this grid, can you see the different squares labeled from 0 to 95? There are 96 different channels to record from the brain. So in the channels of the electrical signals run. That's the basic concept here. So can you see how clustering is used? I used hierarchical clustering, this algorithm, to tell me what the similar channels are. to train my machine learning model to decode, for example, the movement of swallowing. When a person swallows, how can a machine learning algorithm know that? When you're able to group the similar behaviors and assign labels. So Hindu, we don't have any labels. I don't know what these channels are. I don't know any features of them. I'm using unsupervised machine learning. So can you see I have 5 different clusters. I ran the machine learning code, and this is my output. So on the grid there, you can see on the left-hand side, there are so many similar channels. And then when you look towards the right-hand side, they come under a different group, under cluster 5. How could I analyze this using the tool or algorithm of clustering? So this is a great example of what clustering does. It just groups similar data. That's simple. But it's so useful when you don't have labels for your data. This is just one real-life application of what clustering is used for. So just like this in your projects, you will need to know, okay, should I use clustering? Should I use a supervised learning algorithm? உங்களுக்கு அந்த knowledge இருக்கும். You need to know that concept. Do you understand what clustering is now?
They don't understand what clustering is.
Alright, wonderful.
Okay, now let's move on to the next part, that is reinforcement learning. Now, do all of you play chess? You all know the game chess?
Please raise your hands for this,
Please.
yes? How many
Yes or
of you
no?
chess?
How many of you play chess or know the game chess?
Okay, some of you. Okay, how many of you play carom? Few more. Okay, how many of you play, let's say, table tennis? Okay, any board games? Video games? I see a lot of hands up. Okay. Now, what is reinforcement learning?
When we talk about reinforcement learning, we're talking about a machine learning program that has something called an agent. Now, what this agent does is, suppose you are playing chess, right? Now, this agent is part of your computer program. The agent is used to perform moves in chess. In chess, we have a lot of moves. Now, when the agent makes a certain move, it gets rewarded based on whether that move is correct or not. So let's just say, I think you can move the pawn straight 2 squares, if I'm right. Does anyone know how to play chess? You can only move the pawn 2 squares straight and 1 square diagonally, if I'm right. Now, let's just say the agent does something wrong. It performs a wrong move, and it moves that pawn 2 squares diagonally, which is not right. Then in that case, the agent does not get a reward, but is penalized by it. This is exactly how reinforcement learning works in machine learning. If the agent makes the wrong move, it is penalized. With this way, it knows what move is correct and what move is wrong. Now with chess, this can also be applied with a lot of games. There are a lot of machine learning algorithms that are used to play a lot of games, such as carom, we have chess, and we also have a game called Go.
So one of the students here mentioned that they wanted to use AI and machine learning for video games. So if you're doing that, then you need to focus on reinforcement learning. And many of you might not know, but Google has a different or subset called Deep Blue. Google's deep learning team, Deep Blue. If you don't know, please write it down and you can search that later. There is this beautiful documentary on YouTube called AlphaGo. It's spelled as ALPHAGO. And this beautiful documentary showcases how Google has spent 10 years developing a reinforcement learning agent to play this game called Go. It's a board game with different moves. What's so interesting is the number of moves you can make in Go, the number of different combinations is more than the number of atoms in the universe. So think about how complex this game is. And they show you how reinforcement learning is used to train an agent, an algorithm, to beat a human at the game. It is an amazing documentary, and it will show you how reinforcement learning and AI is being used in the real world. So please, if you have time, please go watch it. It's called AlphaGo by Deep Blue, and it's by Google's DeepMind team.
Okay, now we come to quiz number 4. Now this tests us on what we've learned so far about unsupervised learning and reinforcement learning.
So quickly refresh those topics. Unsupervised learning, what did we talk about? The different algorithms, we talked about clustering, why it's needed, and reinforcement learning agents when you're playing games. Alright?
Okay, should we start with this quiz?
Okay, I think this time we'll give out some pens.
Sure. What is the specific goal of unsupervised learning? Now, with this quiz, I want everyone who knows the answer. I want you to come to the stage and give us the answer.
Quick.
Quiz.
So please,
Please come up.
what is the answer? What is the goal of unsupervised learning? Yadakanga unsupervised learning use funding. Why do we need this if we have supervised learning? We talked about this. Quickly, I want one volunteer from this side. Please come up. One volunteer from here.
Please, we want two volunteers to come
A,
up.
B, C, or D.
Or D.
You have to come up the stage. Quick.
You also receive a special pen.
You receive
Whoever
a
comes
special
up the
prize.
stage.
Guys, it's a free prize for just walking maybe 20 steps. Come on, confidently. I want you to, this is not a test of your knowledge only, it's a test of your confidence. Can I have a huge round of applause
Please come up.
for the student who's coming up even from the back? Please, a huge round of applause. Yes.
Yes, please come up. Well, what do you think the correct option?
Why do we need unsupervised learning? What is the answer?
Option B.
Okay, to
Okay.
classify data into categories. Alright, is that correct? Let's think about it. Thank you for answering. So, any other answers? To classify data into categories. Is that why we need supervised learning?
Do we think B is correct or is it another answer?
I'm going to give one more chance for a volunteer to come up.
Yes, please come up.
Yes, come up. Please come up.
Please come up to
Yes,
stage.
you round of applause. I see you all hesitating between your friends, but trust me. See, today we're here on the stage conducting this workshop. But what we want is in the next year or two, we want you to be conducting a workshop or a class with your knowledge. Alright, yes?
Yes, what is the correct option? Answer C. To discover hidden pattern instructions in data. Is this option right?
How many of you say yes? Yes. This answer is correct.
Congratulations, great job.
Please take the pen as
Yes,
well.
please take one minute.
Why do we need unsupervised learning? Remember what I said. Supervised learning is when we have labels. Unsupervised when we don't have labels, and when the model has to get patterns and features from unseen data.
Okay, let's move on to our next question. What is the primary application of clustering algorithms in unsupervised learning?
Why do we need clustering algorithms? We saw a beautiful example for
It's
this.
a very easy question.
What does the algorithm do? Why do we use it?
What is the meaning of clustering?
Anomaly detection, predicting future values, grouping similar data points together. What is the answer? Quick, I need one volunteer at least to come up.
Please, we want one more to
You
come up
have
and answer.
quicker responses now. What is the answer?
Well, what is the correct option?
B. Grouping similar data points together.
Okay, grouping similar data points together.
Is this the right answer? And you are correct.
You are correct. Great job. Please
Congratulations.
take a pen.
Clustering is used to group similar data points. I showed you a real-life example how we group similar brain signals together to feed into a machine learning model.
Okay, in reinforcement learning, what is the agent's role when interacting with an environment? We talked about reinforcement learning and specifically the agent's role. We talked about something called penalizing and rewarding. So what do you think the option is?
A, B, C, or D?
D.
What is reinforcement learning? Refresh your memory.
What is
I think
reinforcement learning?
Yes.
We want one to come out. So,
Reinforcement learning is especially useful for games and building agents for this.
yes, what is the correct option? Option D, to maximize the total reward over time. Is this the right option?
Yes, and
Yes, good job.
Alright, wonderful. What does the agent do? It is trying to maximize a reward. If it makes the wrong move, it is penalized, and that's how the model learns on its own.
Okay, what is the primary role of rewards in reinforcement learning?
Very easy. I want the answer from the audience for this.
Is it A, B, C, or D?
What is the primary role of rewards? Why do we need rewards in reinforcement learning? It's the main objective. Yes, please come on.
Yes, please come up to stage.
She says option
Option
C,
C.
to guide the agent's learning by providing feedback. Is this correct?
Is this the correct answer?
How many of you say yes? Raise your hands. Oh, I think only a few people say it's correct. But yes, it is correct.
Correct.
Great
Good
job.
job.
You can take a pen as you read. So why do we need rewards? Rewards are feedback. We are providing feedback to our machine learning model. Alright, next.
Okay, next one. Which type of task is commonly associated with unsupervised learning? What do we use unsupervised learning for? Is it classification, clustering, reinforcement learning, or regression?
Now think about the question here. What is the task? Remember I told you the type of task. You have to be very specific. Is the task classification, clustering, regression, or reinforcement learning?
Do we have at least one volunteer come up with this
Quickly,
session?
yes.
Please come up.
Please come up. Huge round of applause for people who are coming up from all three over there.
Please come up.
I want you to think very carefully here. We talked about different types of tasks. We talked about two different types, subtypes of machine learning. Yes.
Yes, please come up.
Actually, answer.
The answer is B. Okay.
B, okay.
So we have the answer as B. The type of task is clustering. Alright, this might going to be very careful of the name. Let's see if that's correct. Any other options? I
Do we have
to
any
it's
other
right or
option?
wrong. Because I want you to think about this. Yes? Please come up.
Please
We have
come
one
up.
hand up. You think it is C.
It's C, okay.
Okay,
Reinforcement learning.
reinforcement learning. Okay. Reinforcement learning is another type of machine learning. So what are the three fields that we saw? Supervised, unsupervised, and reinforcement. But good try though. Thank you for the answer.
Okay, do we have any more tries?
Any other option? Just yell it out. What do you think it is?
What do you think it is?
Regression? Is unsupervised learning used for regression? Clustering?
Cultivate?
Alright, this may have been option A. Okay,
A,
classification.
classification.
I got all the answers, A, B, C, and D for this one. It might be a little bit hard. Let's see what the right answer is, and then I'm going to explain to you why.
Can we go to the next slide?
Alright, the answer is clustering. Good job. So you did get it correct. But the reason we mentioned you to think about it carefully is unsupervised learning is also used for classification. But the type of task we're focusing on is clustering. So be very good. Alright, thank you so much. You can take a pen as you.
Thank you so much. Next slide. Okay, now, before we go on with our project, shall we all have a quick 10-minute break?
Can we have a short 10-minute break?
Can we have a short 10-minute break before we go on?
Now, if that's alright, we'd like them to have a short 10-minute
Short
break.
10-minute break.
And then we'll get back.